Good morning, my fellow scientists. It is Thursday, June 8th, 2017. I want to talk about an article I read in Slate yesterday. Really interesting subject. The notion was that a few years ago, this psychologist and parapsychologist published an article describing a series of experiments that seemed to show that psychic powers, ESP, precognition, are real. And usually, the skeptics will say, well, you just didn't design your study right. That's why you're seeing psychic powers in your experimental results. You didn't control your experiment well enough. And so random effects are starting to look like what you're looking for. You're chasing noise. This study, however, was very carefully designed, essentially as good as any other experiment in psychology showing any conventional result. And that is a problem for the psychological experimental enterprise. If you can show that psychics are real using what were considered rigorous experimental protocols, then psychology has concluded those experimental protocols are simply insufficiently rigorous. And so the whole field of psychology has been improving the statistical rigor of their experimental techniques in order to raise the bar of proof so that what is presumed to be random noise can't give you these kinds of results. And I've certainly had my share of chasing noise and thinking that they were positive results. In particular, I had an experimental program where I looked for the effect of amyloid beta on synaptic vesicles. That is, the brain has these tiny little packets of neurotransmitter that it releases between cells in order for cells to communicate. And there seemed to be some evidence that amyloid beta, the protein associated with Alzheimer's disease, might be causing cell membranes to leak. And if amyloid beta caused synaptic vesicles to leak, that could lead to all kinds of problems. And so I set out to test that. And I saw all kinds of crazy stuff until I realized that the whole experiment that I had designed was really, really time dependent. So if you control time, if you control how long every step of the experiment was taking, everything I was seeing, all the exciting results, all the leakage, all the apparent differences between amyloid beta and the controls, they all went away. And that kind of subtle experimental detail was easy to miss, and it would have been really easy for me to be completely honest and say I had seen an effect of amyloid beta on synaptic vesicles, and it would seem to me like that was true, despite the fact that what I was seeing was noise that I simply hadn't been careful enough to exclude. That kind of subtle experimental detail is supposed to be corrected by replication studies. So some other group would have seen my bad result and they would have tried to repeat it in a different context and it would have failed because I was chasing noise and didn't know it. And that's how science self-corrects. But if we don't have enough statistical rigor, then crazy stuff will sneak through. And I think that this was a good thing. It was a good thing that this psychologist has raised the bar of proof for his whole field. And I don't know that was his goal, but it's a great story, and I recommend you read it if you have the opportunity. If you like hearing about science and the scientific enterprise, I hope you'll tune in tomorrow. We update Monday through Friday, and we talk about experiments, experimental results, and the scientific enterprise here in the Ion Lab.